Good morning, ladies and gentlemen, my name is Victor. I'm from Lounge Before Work. On this lesson we are going to talk about something interesting about assembly. Yeah, like Visual Studio, C++, and the most interesting things, how really ESP works in MASM. Okay, let's start. And we start. So let's start from the very beginning. Source files. What you need to do, you just need to create main file. Here you just need to create main CPP. That will be our main folder where we will start all of our code. So here I will just start actually everything I want. And this will be my printf, of course, function. Let's include this one, let's include that was stdio.h, and that's almost all, yeah. I just need to return 0, and it will be a printf function with all of these things. And let's write here hello variable, yeah, because we need a variable in this section. Let's start this and let's see if it works. It takes time, of course, yeah, because it's like too old computer. Hello variable, perfect. Yeah, now we have almost executable everything. Okay, now let's see. There is a file. I would like to create a file that will call like ISM. This file we will call hello, maybe not actually hello, but sum, or ft_sum function template sum. Let's be ft_sum, yeah, that will be nice. So what we need to do, we just need to go to properties and include all of the files that we want to include, everything here. But there is a problem. If you go to your properties, you can't find here actually Microsoft. Where is my Microsoft assembly? There is nothing like that. So we should go to our project. We should go to, if I'm not mistaken, build dependencies, build customization. There is a build customization, and as you can see here, you can see MASM. Let's press on it, yeah, and press OK. Then you can go to your properties, and wow, for God's sake, please, yeah, Microsoft Microassembler. That's perfect. Yeah, let's click apply and OK. And now that's impossible. Or no, that's possible. Let's see. Oh no, that's impossible. Yeah, unexpectedly end of file occurred. Yeah, there is a file. We should just compile it, but there is nothing similar. So what we need to do here to use extern. Use extern in C function. Let's name it int, and let's name it sum. I think sum function. Let's write here int a and int b. So our idea will be here to create a function sum with two variables. Okay, very simple. Extern C tells our compiler that will be our C language. Yes, somewhere here you should find it here. Okay, and here we don't need to create anything because this function will be created somewhere here. And as you can see as green, that's normal for Visual Studio. So we will just go to our file ft_sum. And actually I don't want to create f_sum, it will be ft_sum, of course. And it will be sum, let's call it sum. And let's use something like that, something like ft_sum from 3 and 4. And so here we may do something like %d and sum. This will be our printf function with all of our variables, yeah. So what we expect here is to see hello variable, and variable will tell us that, oh, hi, I'm like 7, and that will be perfect. So what we need to do, we just need to go to our file. First of all, 686. Secondly, there is a module, let's call it flat as usual, and here we will use C language. There is a code also, and here we will create our own first function in this series. So let's call it, of course, ft_sum, as we can see here. And we need to add pros. Pros, that's about procedure, yeah, but shortly to the pros. So, and you need to like set here an end of your procedure. You don't need to write in procedure, you just need to write np and end of your function. And I think that's almost all, but there is one thing. Also you need to write return, but you don't need to. One thing, you can't compile if you do that in x64, because that's a model in x86, yeah? So you just need to switch it, and let's see if it works. Okay, yeah. Okay, perfect. There is a garbage here. So, what we need to do? What we need to do now, we just need to create something like another variable to work with. So, actually, there is a EBP pointer. There is something that I drew before. So let's imagine, yeah, you have EBP pointer. When you are here, you may think about that. That's a local data. A local data inside of this function will be placed somewhere, and this data is dedicated to this pointer. So this pointer like is working with local data. That's like very simple. So this pointer will help you to work with. I think I will add 2 more videos how does this function works. It is just stack, and so you will understand completely how does it work. Okay, so firstly, we need to do something like push EBP. Push EBP allow us to come back to our function. So this one is like 100%. We're just pushing this one to a stack. Okay, this is 100 important. 100 question important. Sorry. Allow us to return later to our function. The next one. What we need to do, we just need to move our EBP. Oh, sorry, it should be like that. ESP. So our extended stack pointer should be instead of EBP. If I'm not mistaken, I think I do mistaken. Yeah, let's do exactly this one. So EBP will be. So what I'm doing here, I'm just trying to copy data from my address from my ESP to my EBP. So now I'm working with my EBP data, and I will be pointing in my memory. So if you want to do what's exactly happening, I'm pushing this EBP to my stack, so it will be suitable for me to work with, to like call it later, and then I can like convert, not actually convert, but address a data from ESP to EBP. So now local data will begin from this place, from ESP place, where ESP placed, and this will be also suitable. So that will be somewhere here. Of course, after this one, you need to pop your EBP, because that's like important one, and you need to return. If yeah, I'm doing that in wrong place. Let it be here. Okay, perfect. I think that's almost enough. Yeah, so we need now 2 more accumulators to place our variable. Our variable placed like EBP, so just like our function, there's on this plate there's like return something. You can see this on the video, and like there is a 4, for example, if it's like 4 bytes, and this one is like 8 bytes. So first our parameter will begin from 8 bytes, so it will begin from here, yeah. So here we'll have our first data like 3, and here 12. From the very beginning, yeah, it will be 4. So we need to add all of these variables and return numbers. So what we need to do, we just need to place 3 on, I think, EAX. Let it be in EAX. This one on ECX, and all of that will be placed again, I think, in EAX again when we would like to edit. So we need 2 commands: move EAX, and we'll use this command to place our variable. So what we need to do, we just need to get EBP here plus 8. So that's first of our address, as I show you, yeah, plus 8 bytes, because that's how we get and like data here, data from this address. The next one we will use ECX. It will be 12, and another one will be add to EAX our data from ECX. Very simple, yeah. So, and also we need to return EAX. So that's a value that we will return to our compiler, yeah, from our function. Okay, and also we can start the thing. I think it works now, yeah. So again, what's happening here? This one allows us to return later to our function. This one helps us to work with stack pointer. Yes, our stack pointer will begin from like our basic pointer will begin from stack pointer place. We will add a few data using a logic of memories. And again, we will end our function with these two columns, yeah? Okay, let's start and see if it works. Okay, yeah, now we have variable 7, perfect, yeah. If you have any questions, yeah, you can write. I think we can continue with the series if you do like, so yeah, write the comments and I am waiting for you, okay? See ya!